Okay, we have here to another interesting integral from the UNSW Integration Bee 2023, problem 3. We have the integral of 1 over square root of 1 over x squared minus x squared dx. Okay, now at first this looks kind of intimidating and a little bit different, but what I can do actually is factor this. So let's see what happens. What I want to do, I think, is factor out a 1 over x squared. So let's just rewrite. We'll pull 1 over x squared in front. And so what's going to happen is inside the parentheses we'll have 1, and then this term minus, this will become x to the fourth, just noticing x to the fourth times 1 over x squared gets us back to this x squared right here. But then from there what I can do is pull this 1 over x squared outside of the parentheses. We're inside the square root, so that's going to give me 1 over x here. But when I rewrite this, we have 1 over x in the denominator, I can write that as an x in the numerator. So we'll have x dx over 1 minus x to the fourth. But now at this point, this looks pretty good for a trig substitution. It's very similar to having 1 minus x squared. But because usually when we do a trig substitution, we have 1 minus x squared here, and instead we have 1 minus x to the fourth, I think it might be nicer if I do a u substitution first. So what if I do this? We'll say our u is going to equal x squared. Then if I take my derivative, we find du is equal to 2x dx. And then again, just to make it clear, if we have u equals x squared, then u squared equals our x to the fourth that we have right here. Then before we do the substitution, we have x dx here in the numerator. We want 2x dx. If I just multiply by 2, now we have du here in the numerator exactly, but I'll multiply by 1/2, just so that I'm not changing the problem. Now let's rewrite. We'll have 1/2 in front. Again, this is our du. And then here in the denominator, we're going to have square root of 1 minus, this here is going to be u squared. But now for this, it turns out we really don't need to do trig substitution on this, because this is just a common integral. We know that this is actually the integral of arcsine. So when we integrate, we're going to have 1/2 arcsine of u. Then all I need to do to finish it off, just back substitute. So for our final solution, we're going to have 1/2 arcsine x squared plus c, and that's it. Okay, good quick problem. We'll stop it there. Thanks everyone for watching. Have a good day.